Gabriel synthesis is used for the preparation of primary amines. Phthalimide on treatment with ethanolic potassium hydroxide forms potassium salt of phthalimide, which on heating with alkyl halide followed by alkaline hydrolysis produces the corresponding primary amine. Aromatic primary amine cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution reaction with the anion formed by phthalimide. Now let's see how this reaction takes place. This is the phthalimide. Here there are two carbonyl groups directly attached to nitrogen. Carbonyl groups are electron withdrawing group. So they withdraw electron density from nitrogen. When they withdraw electron density from nitrogen, nitrogen develops partial positive charge. And this hydrogen will become acidic hydrogen. Now this hydrogen will become acidic hydrogen when it reacts with KOH. KOH is a base. It undergoes neutralization reaction. As a result of it, potassium salt of phthalimide is formed. So this is the potassium salt of phthalimide. In this salt, nitrogen carries negative charge, and that's why it can act as a nucleophile. When it reacts with alkyl halide undergo nucleophilic substitution reaction. This nucleophile replaces halogen in the form of halide ion. This nitrogen itself gets attached to the alkyl group. So that's how you will get N-alkyl phthalimide. Now the formed alkyl phthalimide undergo alkaline hydrolysis. On hydrolysis, these two bonds will break and nitrogen will get H plus ions and carbonyl carbon will get OH negative ions. But due to the presence of a strong base, this cannot exist as a carboxylic group. It converts into sodium salt of carboxylate. So this is the byproduct of the reaction, and here you will get the primary amine as the main product of this reaction. Now let's try to understand the meaning of last three lines. Here it is written, aromatic primary amines cannot be prepared by this method because aryl halides do not undergo nucleophilic substitution with a formed anion. So let's try to understand why aromatic amine cannot be prepared by this reaction. Here the reason is given that aryl halide do not undergo nucleophilic substitution reaction. So first of all, draw the structure of aryl halide. So aryl halide has benzene ring and here it is bonded to halogen. Halogen has a lone pair of electron. So when these lone pair of electron take part in the resonance of benzene ring, you will get another resonating structure. In this resonating structure, these two bonds will remain as it is. The double bond moves to this carbon in the form of negative charge, and the carbon-halogen bond will become double, and halogen will get positive charge. So when you see in the resonance, the carbon-halogen bond acquire double bond character, and now this double bond is become difficult to break. As it become difficult to break, now this double bond is difficult to break. Because this carbon-halogen bond acquired double bond character, it has become difficult to break this bond. That's why it doesn't undergo nucleophilic substitution reaction with the formed phthalimide anion. That's why aromatic amine cannot be prepared by this method. Now come to the next method. The next method is Hoffmann bromide degradation reaction. Hoffmann develops a method for the preparation of primary amine by treating amide with bromine in an aqueous or ethanolic solution of sodium hydroxide. In this degradation reaction, migration of alkyl or aryl group takes place from the carbonyl carbon of amide to nitrogen atom. The amine so formed contains one carbon less than the present in amide. That's why the name of this reaction is degradation, because it degrades the one carbon from the starting material. Now let's examine the reaction. Here this is RCONH2. CONH2 is amide. This is amide. when it reacts with bromine with aqueous or ethanolic solution of sodium hydroxide, means there is a strong base. When it reacts with Br2 in presence of NaOH. So here this alkyl group migrate from the carbonyl carbon of amide to the nitrogen atom. So it will migrate from this carbonyl carbon to nitrogen of amide. So it will get attached to NH2. So that's why here RNH2 is written. And this CO is removed in the form of Na2CO3 and NaBr and water are formed as a byproduct. So let's try to understand. So let's take one example of this reaction. So here if I draw CH3 C double bond O NH2. This is ethanamide. When it reacts with Br2 in presence of NaOH. As it is written here, alkyl group migrate from carbonyl carbon to nitrogen. So here this is the alkyl group. Now it will migrate from carbonyl carbon to nitrogen. So here you can get the product CH3NH2. So the product is methanamine. And it is formed from ethanamide. In the starting material, there were 2 carbon, while in the end product, there is just 1 carbon. That's why this reaction is named as degradation reaction. Now let's solve these examples. Write the chemical equation for the following conversions. In the first question, you have to write the reaction for the conversion of chloroethane into propanamine. So let's try to write the reaction. How you can get propanamine from chloroethane. So here this is first of all write the starting material. The starting material is CH3 CH2Cl and the end product that we has to form CH3 CH2 CH2 NH2. This is chloroethane and we have to prepare propanamine. So propanamine can be prepared from, so let's start from the product. So propanamine can be formed by nitrile, propane nitrile. So here you can write CH3 CH2 C triple bond N. So this is propane nitrile. So this propane nitrile can be formed by the nucleophilic substitution reaction of chloroethane. So if we can substitute Cl by Cn, you can get propane nitrile from chloroethane. So here, if we use KCN or NaCN, you can get propane nitrile, and this propane nitrile can be reduced into propanamine by using LiAlH4. Now come to the second question. Here C6H5CH2Cl means benzyl chloride into C6H5CH2CH2NH2. So let's draw the structure. Here this is benzyl chloride, benzene, CH2Cl, and we have to prepare, this is benzene, CH2, CH2, NH2. Now select the longest carbon chain. So here it is 2 carbon long chain and there is a substituent of phenyl. So here you can write the name of this molecule. This is phenyl ethane amine and this is benzyl chloride. So let's start from the product. So this can be prepared from the reduction of nitrile. So draw the structure of nitrile from which this can be prepared. So here this is benzene, it is bonded to CH2 and when it is bonded to C triple bond and. First of all select the longest carbon chain. So here it is 2 carbon long chain and phenyl is the substituent. So the name of this molecule will be phenyl ethane nitrile. So this can be prepared by the nucleophilic substitution of benzyl chloride. So here you can prepare this molecule by the nucleophilic substitution of benzyl chloride. So when benzyl chloride undergo nucleophilic substitution with NaCN or KCN, you can get phenyl ethane nitrile and after the reduction of this nitrile with LiAlH4 you can get phenyl ethane amine. Now come to the next question. Here write the structure of IUPAC names of amide which gives propane amine by Hoffmann bromide degradation reaction. First draw the structure of propane amine. Propane amine means CH3, CH2, CH2 and this is NH2. So this is the structure of propane amine. Now we have to form this propane amine by Hoffmann degradation reaction. In Hoffmann degradation, alkyl group migrate from carbonyl carbon to nitrogen of amide. So now draw the structure of reactant. So here you have to draw the structure of amide in which alkyl group will be the propyl group. So here when you draw the structure of amide CH3, CH2, CH2 and it is bonded to C double bond O, NH. So this is the amide group. In Hoffmann bromide degradation, you have to migrate this alkyl group from carbonyl to nitrogen of amide. So that's how you can get propane amine. Here reagent will be Br2 in presence of NaOH. So this is the structure of amide from which we can prepare propane amine by Hoffmann bromide degradation reaction. Now write the name of this molecule. First of all select the longest carbon chain. There is 4 carbon long chain. So the name of this amide will be butane amide. So propanamine can be prepared from butanamide by Hoffmann bromide degradation reaction. Now come to the next question. The amine produced by Hoffmann degradation of benzamide. So here you have to draw the structure of amine that can be prepared by Hoffmann degradation of benzamide. So let's draw the structure of benzamide. Benzamide is benzene. Here this is C double bond O NH2. So this is the structure of benzamide. So when it undergo Hoffmann degradation, you have to migrate alkyl or aryl group which is bonded to carbonyl carbon to nitrogen of amide. So here you will get the structure of amine. This is benzene which will migrate to nitrogen. So here you will get NH2. So this molecule will be benzylamine, or the other name is aniline. Aniline can be prepared benzamide by Hoffmann degradation reaction. Now come to the next question. How will you convert benzene into aniline? Here you have to convert benzene. So let's draw the structure of benzene first. This is benzene and it has to convert into aniline. Aniline means benzene and NH2. So this is aniline and this is benzene. So let's start from the product. Aniline can be prepared by the nucleophilic substitution of chlorobenzene. So here I can draw the structure of chlorobenzene. So this is chlorobenzene. Now you have to think how you can prepare chlorobenzene from benzene. So when benzene undergo electrophilic substitution reaction with Cl2 in presence of Lewis acid, the Lewis acid that you can use can be AlCl3 or it can be FeCl3. So when benzene is treated with Cl2 in presence of Lewis acid, chlorobenzene can be prepared, and when chlorobenzene undergo nucleophilic substitution reaction, means ammonolysis. After ammonolysis, you can get aniline. So here you can use NH3 in excess in presence of ethanol. Now come to the second question. Benzene into NN-dimethyl aniline. Here let's draw the structure of reactant and product, the starting material and the end product. Here this is benzene and here you have to prepare NN-dimethyl aniline. Means here aniline means nitrogen will be there and there are two substituents bonded to nitrogen. So here one side it is bonded to methyl CH3 and other side also it is bonded to CH3. Now you can get the idea how we can prepare substituted amine from benzene. First you have to prepare aniline from benzene. So first you have to prepare chlorobenzene. So here if we can prepare chlorobenzene, from chlorobenzene you can prepare aniline. Here this is the structure of aniline NH2, and when aniline react with CH3Cl, you can get N-methyl aniline. Here N, H and CH3. When it further react with another molecule of chloromethane, you can get NN-dimethyl aniline. So now write down the reagents. Benzene can be prepared by chlorination, means Cl2 in presence of AlCl3, you can get chloromethane. You can get chlorobenzene, and when chlorobenzene react with ammonia, here NH3 in presence of ethanol, it will undergo nucleophilic substitution reaction and you can get aniline. When aniline react with chloromethane, again chloromethane undergo nucleophilic substitution reaction and you will get N-methyl aniline. When it further undergo nucleophilic substitution reaction with chloromethane, again you can get NN-dimethyl aniline. Now come to the third question. In third question, you have to prepare Cl CH2 4Cl into hexane 1,6-diamine. So first of all, draw the structure so that we get the clear idea how you can prepare it. So this is Cl, here CH2 4 times, CH2, 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 Cl. And you have to convert it into hexane 1,6-diamine. Means you have to draw 6 carbons, 1, 2, 3, 4, 5 and 6. And first and second carbon has NH2. It is NH2. Now there are 4 carbons and here there are 6 carbons. So first balance the hydrogens. Here CH2, 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 CH2 and CH2. So on both the sides you have to increase 1 carbon. So how you can increase 1 carbon on both the sides? If we can substitute Cl with Cn. Here to increase the number of carbon you have to introduce nitrile group. So here you have to introduce C triple bond N on both the sides. So here this is CH2, 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 CH2 and on this side also we have to add one nitrile. And then after the reduction of this nitrile you can get hexane 1,6-diamine. Now write the reagent. For the addition of nitrile group, here you have to react this molecule with NaCN, 2 moles of NaCN to replace 2Cl with 2 CN groups. You require 2 moles of NaCN. Now when it undergo reduction, so LiAlH4 can reduce this nitrile into amine. That's how you can carry out third conversion. In the next video of amine, we are going to discuss physical properties of amines.